Hi everyone. We are still on the sine rule, but this is the last problem we are going to solve under the sine rule, using the sine rule. When we have completed this topic, we are going to look at graphs of trigonometric functions like the sine graph, the cosine graph, and the tangent graph, and solve problems on them. But somebody requested that we have a look at differential equations. So the next coming videos we'll be looking at differential equations, which are very important aspect in mathematics. So for now, let's look at this problem. This problem here we have on the board is talking about the height of a building. There is a surveyor standing here, position 1 and later position 2, taking measurements of this height, of the height of the building. This is the building here. And so I don't want to write the question here, it's too long, it takes space. So I will read the question later on. I will just explain it first. First, the surveyor stood here at an angle of 40 degrees. You know, those are the instruments they use to measure the height of this building. Then the surveyor moved to this position at an angle of 52 degrees, measure the same height of the building. This height, they want us to find this height with these angles and this distance that is given. And then we are also asked to give one assumption the surveyor has made to get the height of this building. What I need to mention here is, if you are standing on the bottom of a building and you're looking at the top of that building, you want to take the measurement, the height of that building. The angles you have here, these are called angles of elevation. If the surveyor was on the top of this building, imagine she doesn't know the height of the building and still using their instruments and trying to measure the height of this building from the ground, then that angle she'll be making from this point here, they will not be 52 here and 40 here, they will not be like, it will be something different. Those angles are called angles of depression. Here are angles of elevation. Now let me read the question. The question says that a surveyor wants to determine the height of a building. She measures the angle of elevation of the top of the building at 2 points 15 centimeters apart on the ground. I.e., use this information to determine the height of the building. B. State one assumption made by the surveyor in using this mathematical model. What we want here is height. It's not given to us. So let me represent that by h. A triangle like this, there is no way we can just solve it directly. Because if you look at this smaller triangle from this one here, what do we have here? There is nothing here. You only have angle. Nothing here. Nothing on this line. You can't solve it. It's not possible. If you look at the bigger triangle, the whole triangle now, ignoring this one inside, you only have this distance here, the degrees, and h. Again, you can't do anything. You can't solve it. There's no way you can solve it with just that information. So we need to add something else. What do we need to do? First, we need to know what this is for this triangle, the smaller one. What is this distance? And then we need to know for the bigger triangle, what this distance is. So if we say the whole of this distance for this bigger triangle is x centimeters, what would then be this smaller triangle here? I have 15 here. If this whole thing is x, so this will be x minus 15 centimeters. So now we have two triangles. A bigger triangle this whole one, and we have a smaller triangle inside one. We have this whole bigger triangle, and then we have a smaller triangle inside one. Now, let me label this triangle. A, B, C, and D. We are now looking at the bigger triangle, which is triangle CAD, angle triangle CAD. Triangle CAD, we are looking at this angle here, 40 degrees. The angle, this height opposites the angle, and we have the adjacent as x. So we are looking at opposite and adjacent. Which trigonometric identity do we use to give us that relationship, opposite and adjacent? We use the tangent. The tangent. So we can now say that tan 40 is equals to the opposite, which is now the h, all over the adjacent, which is x. We are looking at the bigger triangle, not the inside one. So if we cross multiply to make this thing linear, we'll have here x, the tangent of 40 equals h. Let's call this equation 1. So let's now look at this smaller triangle, CBD. CBD. Again, looking at 52 degrees here, you have the opposite, which is h, and you have the adjacent, which is x minus 15. What does that give us? Again, it's tangent. So you have the tangent of 52 is equals to the opposite, which is h, all over the adjacent, which is x minus 15. Cross multiply here, so we have x minus 15 times the tangent of 52 equals h again. This is equation 2. So if we look at equations 1 and 2, you can see that both are equal to h. Equation 1, h. Equation 2 equals to h. According to logic, what is on the left hand side is then equal on the two equations, because x times 40 equals to h, x minus 15 times 52 equals to h, and h is equals to h, which means x times 40 is equals to x minus 15 times 52. So we conclude equation 1 equals equation 2.
Papa,
So therefore, we have x tan of 40 equals x minus 15 tan of 52. So let's expand and collect like terms. We have x, because in this, what you can see now here, we only have one unknown. So which means you can find the value of x. So x, the tan of 40 equals to, distribute x tan 52 minus 15 tan of 52. Collect like terms. So what I would like to do, this minus, I'll bring it over the sign, equality sign, it will now be plus. So I'll have 15 plus 15 tan 52. 15, the tangent of 52. This will give me, I still have my this one here, x tan 52. Now this one here will now come on the right hand side, and it will be now minus x tan 40. X tangent 40. So this will give me 15 tan of 52. So I now have tan 50, x tan 52 minus x tan 40. So I know this 52 minus tan of 40. So therefore x now will be equals to 15 tan of 52 divided by tan 52 minus tan 40. All this is equals to x. So when we evaluate this, then we'll be able to know the value of x. Tan 52 minus tan 40, please don't think it's 52 minus 40, then you say tan 12. It doesn't work like that. You have to find the value of tan 52, the value of tan 40, then you do your subtraction. So let's do that. (15 tan 52). So 15 divided times tangent 52. This will give us, now we have x. Now we'll have x. This will give us 19.199. 19.199. 124. Let's stop there. Minus, okay, it's divided by tan 52. Tan 52. 1.27 7994. Let's stop there. Minus tan 40. 0.839839. Let's stop there. So this gives us 19.19912. Let's stop there. 1.27994 minus 0.8390. We get 0.4409. So let's evaluate this. 19.19912 divided by 0.4409. 43.5452 centimeters. This is x. We find the value of x, but it's not x we are looking for. We want the height, h. But since we know x, we can now use any of these equations that involves x to find h. You can see here that tan 40 equals h over x. We know x already, we can find h. Or here we see that tan 52 equals h over x minus 15. We know the value of x, we can evaluate it here, then we can find h. So we can use now either equation 1 or 2 to find our value of h. So I will take this off. Yeah? I'll take this off. Okay? So now from equation 1, from 1, we know 1 is x. The tangent of 40 equals h. We now know what x is. X is 43. So we can now say 43.5452. The tangent of 40 equals h. So we just evaluate this. 43, 43.8 times tan 40, 36.5, 36.538, which is this centimeters, 36.54 centimeters, or 36.5 to 1 decimal place, or 3 significant figures. So this is your final answer. This is the height of the building, 36 points. Was it meters or centimeters? It's meters. Meters, sorry. It's meters, can't be centimeters. Meters. 36.65 meters. Thank you for watching. If you like this video, you can subscribe, you can follow me, and you can make comments as well. Thank you for watching. Bye bye.